Hello everyone, welcome back to the Data-Driven Hospital series. In the previous episodes, we designed a hospital database and learned how to build it using MySQL. We created tables, defined relationships, and structured the foundation for our hospital information system. Now it's time to turn the database into life. In today's episode, we are taking the data we have generated for the Northbridge Hospital into Microsoft Excel, which is one of the most widely used tools in healthcare analytics. We'll begin by exploring our dataset, understanding its structure, and performing essential data cleaning steps that every data analyst must complete before performing any analysis. We will identify missing values, detect duplicate records, verify data types, and create new variables from already existing data. Along the way, we'll understand how raw hospital data can be transformed to a cleaner, more organized, and analysis-ready dataset. So let's dive into our Northbridge Hospital dataset and begin preparing our data for analysis. For this episode, I've exported the generated data from our Northbridge Hospital database into Microsoft Excel, where we'll perform data cleaning, quality checks, and exploratory analysis. Before we start cleaning the data, let's take a tour at the dataset and understand what information each table contains. Let's begin with the patients table. This is our master patient table containing 10,000 patients. Each record represents a unique patient registered at Northbridge Hospital. The patients table serves as the backbone of our database, because every clinical activity in the hospital is linked to a patient. Next, we have the departments table. This table contains the various departments within the hospital. Each department has a unique department ID and a department name. This table helps us organize hospital activities and allows us to analyze performance by department. Moving on to the staff table. This table contains information about all healthcare workers and support staff employed by the hospital. For each staff member, we have a unique staff ID, name, role, department assignment, contact information, hire date, and employment status. By linking staff to clinical activities, we can monitor workload distribution, staffing patterns, and departmental performance. Next is the outpatient visits table. This is one of the most important clinical data sets in the hospital. Each row represents a patient encounter in the outpatient department. We have visit dates, vital signs, presenting complaints, history of presenting illness, past medical history, review of systems, physical examination findings, laboratory requests, diagnosis, treatment plans, and the attending physician. This table gives us a detailed view of routine patient care and is often the starting point for many healthcare analytics projects. The next sheet contains emergency visits. Unlike outpatient consultations, emergency visits captured urgent and potentially life-threatening presentations. Here we find information on vital signs, emergency contacts, clinical assessments, emergency management provided, investigations ordered, diagnosis and treatment plans. This dataset is particularly useful for studying emergency department workload, common emergencies, and patient outcomes. The next table is the administrator's sheet. This contains information about leadership positions within the hospital. These records allow us to track management structures and organizational responsibilities. Next, we have the antenatal care visits table. This table captures maternal health care services. For each antenatal visit, we record vital signs, clinical assessments, laboratory requests, management plans, and follow-up appointments. This dataset can be used to monitor maternal health indicators, antenatal attendance trends, and pregnancy-related outcomes. Moving on to the pharmacy visits sheet. Every time a patient receives a medication from the pharmacy, a record is created in this table. This table enables medication utilization analysis, prescription audits, and pharmaceutical inventory planning. The next sheet contains imaging visits. This table records radiological and imaging services requested across the hospital. Examples include ultrasound scans, X-rays, CT scans, and magnetic resonance imaging examinations. This dataset helps evaluate diagnostic imaging utilization and clinical decision-making patterns. Next, we have the laboratory visits table. This is where all laboratory investigations performed for patients are recorded. Laboratory data often forms one of the richest sources of clinical information within healthcare analytics because it provides objective measurements of patient health status. The next sheet contains admissions. This table captures patients who required hospitalization. We record admission dates, admitting diagnosis, wards, attending physicians, discharge information, and patient outcomes. Using this dataset, we can calculate important hospital performance indicators such as average length of stay, bed utilization rate, readmission rate, and inpatient mortality. Next, we have the follow-up visits table. These records contain review dates, clinical progress notes, treatment adjustments, and future management plans. Analyzing follow-up data helps us understand treatment effectiveness and patient retention within the healthcare system. The procedures table comes next. This sheet contains information about medical and surgical procedures performed within the hospital. Procedures may range from minor interventions to major surgical operations. This dataset allows us to study procedure volumes, utilization trends, and outcomes across different specialties. Next is the billings table. Healthcare organizations must also manage financial information. This table contains billing records associated with patient services, consultations, investigations, admissions, and procedures. Financial data sets are essential for revenue cycle analysis, service costing, and operational planning. The next sheet contains ICD codes. ICD stands for International Classification of Diseases, and this standardized coding system is used worldwide to classify diseases, health conditions, and causes of death. Rather than storing diagnosis as free text alone, healthcare systems often map diagnosis to ICD codes, allowing for standardized reporting, research, and epidemiological analysis. Finally, we arrive at the Loing table. Loing stands for Logical Observation Identifiers, Names, and Codes. It is an international standard used to identify laboratory tests, clinical measurements, and observations. Instead of recording laboratory investigations using inconsistent names, healthcare systems use Loing codes to ensure that tests are represented consistently across departments, hospitals, and even countries. Now that we have explored the structure of our Northbridge Hospital dataset, it's time to begin one of the most important stages in any data analytics project: data cleaning. In healthcare analytics, the quality of your insights depends entirely on the quality of your data. Even the most advanced dashboards, statistical models, or machine learning algorithms can produce misleading results if the underlying data contains errors, inconsistencies, or missing information. For this demonstration, we'll focus on the outpatient visits table. This is one of the most information-rich tables in our hospital database, containing patient demographics, visit dates, vital signs, diagnosis, and clinical encounter details. Let's begin by assessing the quality of our data. Our first task is checking for missing values. Missing values are one of the most common data quality issues encountered in healthcare datasets. They can arise from incomplete documentation, system failures, or simple human oversight during data entry. There are several ways to identify missing values in Excel. The first method is the F5 technique. I'll select the data, press F5 on the keyboard, choose Spatial, and then select blanks. Excel immediately highlights all empty cells within the selected range, allowing us to quickly identify missing information. The second method is using filters. By applying filters to each column, we can select blank values and immediately see which records have missing entries. This approach is particularly useful when investigating specific variables such as diagnosis, blood pressure, weight, or temperature. The third method uses formulas. For example, we can use the isBlank function, or a formula that counts blank cells within a column. Once we have identified missing values, we can decide whether to leave them as missing, replace them, retrieve them from source records, or exclude them from specific analysis depending on the context. Next, we'll check for duplicate records. Duplicate records can significantly distort healthcare metrics by artificially inflating patient volumes, disease prevalence, and service utilization statistics. One simple method involves selecting the entire dataset and applying conditional formatting. I'll navigate to the conditional formatting, select Highlight Cell Rules, then choose Duplicate Values. Excel automatically highlights any duplicate entries, making them easy to identify and investigate. It's important to remember that not all duplicate values are necessarily duplicate records. For example, multiple patients may share the same diagnosis, and a patient may legitimately have multiple visits. Therefore, duplicate should always be interpreted within the clinical context. The next step is verifying column data types. This is a crucial but overlooked aspect of data cleaning. We'll inspect each column and determine whether it contains the correct type of data. For example, visit dates should be recognized as dates. Incorrect data types can lead to calculation errors, sorting problems, and inaccurate analytical results. Now that we have assessed the quality of our existing data, let's begin creating new variables that will make our analysis more meaningful. The first new column we'll create is the visit month and year. While the visit date tells us exactly when a patient attended the hospital, analysts often need summarized information for monthly reporting and trend analysis. Using the visit date column, we'll extract the month and year for each visit. This allows us to answer questions such as how many patients visited the hospital each month, which month experience the highest patient volumes, are there seasonal patterns in disease occurrence. Next, we'll calculate the body mass index, commonly known as the BMI. The BMI is calculated using the patient's weight and height and serves as a simple indicator of nutritional status, the formula being weight in kilograms divided by the height in meters squared. After calculating the BMI for every patient, we'll create another column called the BMI category. This categorizes patients into clinically meaningful groups: underweight for BMI less than 18.5, normal weight for BMI between 18.5 and 24.9, overweight for BMI between 25 and 29.9, and obese for BMI of 30 or greater. Categorizing BMI allows us to study prevalence of overweight and obesity within our patient population, and as well to explore relationships between BMI and disease patterns. Next, we will work with the blood pressure column. Currently, blood pressure is stored as a single value in the format systolic/diastolic. For analysis purposes, we need these values in separate columns. Using excess text-to-column feature, we'll split the blood pressure field using the / as delimiter. This creates two new variables, systolic blood pressure and the diastolic blood pressure. Having these measurements separated allows us to calculate averages, identify hypertensive patients, and perform cardiovascular risk analysis. Next, we'll derive several new clinical classification variables from our vital signs data, starting with the pulse rate. We'll create a pulse category column. Patients with pulse above 100 beats per minute will be classified as tachycardic. Patients with pulse rate below 60 beats per minute will be classified as bradycardic, and patients between these values will be classified as normal. Next, we'll categorize body temperature. Patients with temperatures below 36.5 degrees Celsius will be classified as hypothermic. Patients with temperatures above 37.5 degrees Celsius will be classified as hyperthermic, and all others will be classified as normal. We will then categorize respiratory rate. Patients with respiratory rates greater than 20 breaths per minute will be classified as tachypneic, with patients with respiratory rate less than 12 breaths per minute being classified as bradypneic, all others classified as normal. Finally, we will classify oxygen saturation, with patients with oxygen saturation below 95% being categorized as hypoxic. At this point, it is important to make an important clinical observation. The normal ranges we are using for pulse rate, respiratory rate, temperature, and oxygen saturation are simplified adult reference ranges intended for demonstration purposes. In real-world healthcare analytics, normal vital sign ranges vary significantly according to age group. Once relationships between tables are established and patient age information is incorporated into our analysis, more accurate age-specific classifications can be generated.